Okay, so we're going to look at section 5.4. We're going to be factoring quadratics in the expression x squared plus bx plus c, and our a value is 1. So remember, in standard form, we have ax squared plus bx plus c. If the a value equals 1, if this is 1, you're going to see it like this, x squared plus bx plus c. So that's what we're going to be factoring today. Okay, so this is what you guys did in section 5.1, and you expanded it. So you did x times x, and you did it by FOIL, and you got x squared. And then you did x times 3, and you got positive 3x. 7 times x, positive 7x. 7 times 3, positive 21, and then you simplified it. And you got x squared plus 10x plus 21. What you have here is the polynomial. What you have here, x plus 7 times x plus 3, this is factored form. So when we factor, we're doing the opposite of expanding. So this is what you're going to be given, the polynomial, and then you're going to have to do the factored form. And just once again, a reminder of what factoring is. It's changing a question where you're adding or subtracting terms, and now you're multiplying. So x plus 7 multiplied times x plus 3. So you're going to go from the polynomial to factored form. There is a relationship between the number 21 and the numbers 7 and 3. The number 10 and the numbers 7 and 3. And this is where you need to see the relationship. So think about 7 and 3 and how you can get 21. 7 times 3 is 21. Think about 7 and 3 and how you can get 10. 7 plus 3 is 10. So what you're going to be given is the polynomial. You're going to be looking for two integers that multiply to this number here, which we call c, multiplies to c, and adds to the b value. Let's look at some examples. Now, all of these can be factored. Your textbook uses this quite a bit, factor if possible. There are times that you cannot factor it because we're looking for integers. Okay, so let's look at this, x squared plus 9x plus 18. So to factor it, so going from the polynomial to factored form, I'm looking for two integers that multiply or have a product of 18. So my product, I'll call that p. Remember, product means multiplication, 18. Those same numbers must also have a sum or add to 9, sum of 9. Some people can see right away what those numbers are. Some people can't, and they need to go through the numbers that multiply to 18, like 1 and 18. 1 times 18, 18. 2 times 9. 4 doesn't go into it. 3 goes into it. How many times? 6 times. Like I said, 4 doesn't, 5 doesn't, 6 does, and now we're starting to repeat the numbers here. So which combination, not all of these multiply to 18, but which combination also adds to 9? And it's 3 and 6. 3 plus 6 is 9. 3 times 6 is 18. So now you're going to do two brackets. Whatever variable is here, if whatever it's squared, so you're going to put a single variable in. Because this is positive, I write plus 3. Because this is positive, I write plus 6. Now the order of multiplication doesn't matter. You could have written it the other way like this. It doesn't matter. So if you're checking the answers in the back of the book and the brackets are in a different order, that's fine. You can always check to see that you've done it correctly by expanding it. Okay, let's look at another one. Same idea. Two numbers that multiply to, product is, it's always the c value, so we're looking for a product of our c value, a sum of our b value. Okay, so a product of negative 24 and a sum of -2. So take the sign with it. Whenever we introduce negatives, sometimes people have a little bit more difficulties with it. You're going to do the same idea. Look for the numbers that multiply to 24. So 1 and 24, 2 and 12. Does 3 go into that? Yep. 3 and 8. Does 4 go into it? Yes. 4 and 6. Does 5? No. 6, yes. Now we're starting to repeat the numbers we've got. Now, it needs to multiply to a negative and add to a negative. So I know that if I have two integers and it multiplies to a negative, I know one of the integers must be negative. Okay? I can't have them both being negative because two negatives multiplied together is a positive number, and I need this to be a negative number. So here are my possibilities that multiply to 24. Which of these numbers could I also get to add to -2? So if you look at your numbers, it should be 4 and 6. Which one should be the negative number? Should it be 4 or should it be 6? And this is where people make mistakes. You have to check. If you put the negative on 4, -4 plus 6 is +2, not -2. So I know my negative is right here on the 6. 4 plus -6, -2. So now I do my two brackets. Whatever variable is here, I put in. Okay, so I put my numbers in. Because this is +4, I write t plus 4. Because this is -6, I write t minus 6. Okay, so again, we're looking for two numbers now that multiply to +25 and adds to sum of -10. Now, there aren't too many numbers that multiply to 25. We have 1 and 25, and we have 5 and 5. Now I need this to multiply to a positive, but add to a negative. So you have to remember your integers here. In order for it to multiply to a positive and add to a negative, I know that both of my integers must be negative. And the combination that would do that are these numbers here, -5 and -5. -5 plus -5, -10. When I multiply these, +25. So I do my two brackets. Whatever variable's here goes here. Because they're both negative, I write -5, -5. Okay? Because these brackets are the same, you could have written as m minus 5 all to the exponent 2. Could do either one of these would be fine. Okay, let's move on. So same idea here, two numbers that have a product of -7 and a sum of +6. Again, there aren't too many numbers that multiply to 7. 1 and 7. Once again, if it multiplies to a negative, I know one of these numbers have to be negative. So which one in order to add to +6? It has to be the 1. -1 plus 7, 6. When you multiply it, -7. There are your two brackets. X goes in each. This is negative, so I write -1. This is positive, I write +7. Okay, let's keep going. These are the same. It just looks a little bit different just because of the variables. Okay, but we do the same idea. Again, we're looking for two numbers that have a product of -28 and a sum of -3. So once again, you're looking for the numbers that multiply to -28, but will also add to -3. Okay, so the numbers once again that multiply to 28, 1 and 28, 2 and 14. 3 does not go into here. And you can always check it with your calculator. 4 and 7, 5 doesn't go in, 6 doesn't go in. Now we're repeating it. Once again, this is negative, so I know one of my integers has to be negative. So here are my two numbers, 4 and 7. Which one would have to be negative to add to -3? And it would have to be the 7. Okay. Once again, you do your two brackets. This is an X, put an X in. Because this is positive, I write +4. Because this is negative, I write -7. Now what makes this one different is, do you notice this y squared here? Because of that y squared, I need to include the variable y. So I include it on the last term. Okay, if you're unsure, you can always check by expanding. So if I expanded this, x times x, x squared, x times negative 7y, negative 7xy, 4y times x, positive 4xy, 4 times negative 7, negative 28y squared, and then I have my like terms, but you can always check it. Okay, so then you end up with x squared minus 3xy minus 28y squared, so it works. So if there's a variable here that's being squared, you need to include it in the last term. Okay, last one is here, not last one, in this part. So we're looking for two numbers that multiply to 48, but also add to 19. Okay, so again, you go through the numbers. The two numbers that do that are 3 and 16. They multiply to 48, add to 19. Do your two brackets. Instead of having a single variable here, like the x and the m squareds and the x squared, this is a squared b squared. So that tells me I have to put an ab in for my first term. Because this is positive, I write plus 3. Because this is positive, I write plus 16. Once again, if I'm unsure, I expand it. Okay. The reason we did common factors first is because sometimes you have more than one type of factoring in a question. So you always have to check for a common factor first. This section will prompt you for that, but later on you will not be prompted. You'll be just expected to always check for this first. So I look here at my coefficients. I look for the biggest number that divides evenly into all of them, and I notice it's a 4. So I divide everything by 4, so I get y squared minus 5y minus 14. Okay, once again, I also have to check to see that the variable is present in all terms. And if it is, I would have had to include that, but it wasn't present, so that's why I didn't do that. Now, yesterday when you did this, you stopped here, but today you know more. So now you have to factor what's inside the bracket. This is a trinomial, right? This is in the form x squared plus bx plus c, right? So I'm looking for two numbers that have a product of negative 14 and that add to negative 5. So looking for the two numbers that multiply to negative 14, add to negative 5. The two numbers are negative 7 and positive 2. They add to negative 5, multiply to negative 14. You do your two brackets again. Your variable is y squared, so you put a y in each, minus 7, because plus 2, and you cannot forget that common factor that you took out. And now this one is fully factored. Okay, same idea here, looking for the common factor between, so the greatest common factor between all these terms. So look at your coefficients. The biggest number that goes into all of them are 15. Look at the variable a, is it present in all? And it is. Include the lowest exponent. Look at the variable b, is it present in all? And it is not, so don't include it. Now once again, you're going to divide each of your terms by your common factor, which is 15a, so I'm left with a squared here. 90 divided by 15 is 6, positive 6ab, bases are the same, subtract your exponents. 135 divided by 15, I get positive 9, and again, bases are the same, subtract your exponents, b squared. Okay, so I took out my common factor, I look in my bracket, I can keep going. I'm looking for two numbers that have a product of 9 and a sum of 6. The two numbers that do that are 3 and 3. Keep your common factor, your two brackets. Because this is a squared, you put an a in each, positive 3, positive 3. Because of this b squared, you also need to include it. You can write it like that, or because the brackets are the same, to the exponent 2. This is a very typical question that you can expect. This is where we start making connections between chapter 5 and chapter 4. Now you're asked to factor the right side of the equation fully. Now, it doesn't prompt you to look for the greatest common factor first. And this is more typical of this chapter. You need to check for a greatest common factor always first, regardless of whether or not you are prompted to do so. Okay? So you should always be looking at your questions asking, do I have a greatest common factor? So look at the 3, the 30, and the 48. Is there a number that divides evenly into all of them? And the answer is yes. 3 goes into all of them. Okay? So I have, and it's asking you to factor the right side, this side. So I take the 3 out, and then I look at the x. Is it present in all? And the answer to that is no, so don't include it. So divide everything by 3, so I have x squared minus 10x plus 16. I am not finished factoring because I have a trinomial here that I can factor. I look for 2 numbers that have a product of 16 and that has a sum of negative 10. So looking for 2 numbers that multiply to 16 but also add to negative 10. So as soon as I see this, I see it's adding to a negative, multiplying to a positive. That tells me my 2 numbers must be both negative. Negative 8, negative 2. When I multiply those 2 numbers, I get positive 16. When I add those 2 numbers, I get negative 8. So then I have y equals 3, x minus 8, x minus 2. And now this is factored. This form should look familiar to you. We did this in chapter 4, and it looked like this. Y equals a x minus r, x minus s. That is why we called this factored form, because it's factored. So now we're going to identify what the x-intercepts are. Remember, that's your r value and your s value. Then we're going to find the vertex, axis of symmetry, and we're going to graph the parabola. So remember, the r and the s values are the opposite signs in the bracket. So my r value is 8. My s value is 2. These are my 2 x-intercepts. Now we have to remember from chapter 4, how did we find the vertex and the axis of symmetry, and how did we graph it? Okay, so it doesn't matter what, I'm going to go by a scale here. I'm going to just plot these first. I'm going to go by a scale of 2, just because I didn't leave myself much space here. Okay, so I know one of my x-intercepts is here at 2, and the other one is here at 8. You should know already the direction this graph opens. Should this graph be opening downward or upward? Remember, you look at the a value. Because the a value is positive, you know it's going to open upward. Okay? Remember, the vertex is in between, at the halfway point between the 2 x-intercepts. So once again, to find the vertex, this is review of chapter 4. You're going to take your 2 x-intercepts and divide by 2. Add them together, divide by 2. So I get 10 over 2. So I know my x value at the x-intercept is at 5. So I know my axis of symmetry is right here at 5. Now where's the y value going to go? Well, remember when we did this in chapter 4, we took this x value and we subbed it in here for x. Now you have a choice. You can sub it here for x or here for x. These are really the same thing. Okay? So it doesn't matter if you sub 5 in here or 5 in here. I'm going to go to the original question. Okay, so I'm going to sub x equals 5 into y equals 3 x squared minus 30x plus 48. So then I use my order of operations and I figure out what the y value is. Okay, I keep going, right? And I get y equals 75 minus 180 plus 48, which is y equals negative 27. So I know my vertex is right here at x equaling 5 and y equaling negative 27. So that gives me an idea of what scale I'm going to go by. So I'm going to go by, let's see, if I gave myself enough space. Maybe not. Maybe I'll go by 9s. Negative 9, negative 18, negative 27. Okay, stop there. And then I have my vertex right here at 5, negative 27. I know my graph is opening upward, like that. Put arrows on both ends, and then label it. Okay, so this is the connection between chapter 5 and chapter 4. One last example. Here you're asked, you're given a rectangular prism, you're given the volume, and you're asked to find the dimensions. Remember, dimensions are your length, your width, your height. Okay? The volume of a rectangular prism is length times width times height. Okay? The order of this doesn't matter. It could be height times width times length. Width times height times length. It doesn't matter, okay? So you're given the volume. So I'm given the volume as a polynomial, and I want to know length, width, and height, which is being multiplied. How do I go from a polynomial to multiplication? You factor. And this is a typical application or thinking question. It doesn't tell you to factor it here. You're expected to. So once again, look for the common factor between everything, all the terms. And I notice x is present in all. I look for the biggest number that goes into 6, 5, and 1, which is 1. So I divide all my terms by x. So I end up with x squared plus 5x plus 6. Okay. Now I factor what's here. So I look for two numbers that multiply to 6, add to 5. And I know the numbers that do that are 2 and 3. They add to 5, multiply to 6. So I end up factoring it with my two brackets, right? X plus 2, x plus 3. Okay? And I can call this length, width, height. I could call this length, width, height. It doesn't matter, but these are my dimensions. One is x, one is x plus 2, one is x plus 3. So therefore, the dimensions, make sure you answer the question, are x, x plus 2, and x plus 3. And that's it.